would request sir to please come on the stage and address the gathering. Please, sir.
Ramesh, who met me about a month back and invited me, which I gladly agreed, and now I am really proud to be here and in the August gathering of the Vice Chancellor, Director and the promoters. So it's indeed a great honor to be here. My presentation, of course, will be related to the theme of the conference, the IoT what we have mentioned, Internet of Things. Actually, Internet of Things, though, looks a new buzzword, but it is already outdated. It is already obsolete, actually. The things are changing so fast. Now, instead of Internet of Things, people call it Internet of Everything. I think it's Internet of Everything or device to device. And this may also not be final, it will also change. So my presentation, of course, will be on one aspect of it, which is nowadays called virtualization. And we have called it network function virtualization. Because we have started late, I want to finish at my end time given in this, that is 11:25, I think. So I'll cut short some of the things. And it is related to NGN, actually, the next generation networks. The next generation networks were the futuristic telecom network 10 years back. But now they are also becoming obsolete, and NFV is taking, place for them. The agenda was this, but I'll be actually skipping a lot of this, and finally I'm coming to the application part of it and the real concept of virtualization. Actually, you will see the virtualization is not really a buzzword. It is nothing but what we used to talk 30 years back. 30 years back, we used to talk about automation and IT. IT started happening 30 years back, and that is what is coming actually. According to me, virtualization, which people think as if it is a buzzword, it is nothing but ITification. It is ITification of telecommunication. Telecommunication was a very complex subject, a lot of specialized devices and the systems were used. So now we are taking help of IT, and as you know, IT is nothing but a server and a software. A hardware and a software, and hardware is the server and software is what applications, and on top of that you write. Those things total make the IT. And in telecom also you can do all the functions of a telecom network by the IT. That means by a server and a software. And that is what is virtualization. And you will see how it happens. As well as Professor Mittal mentioned about some of the internet-oriented things actually. So if you see what is driving the changes in ICT, actually nobody nowadays talk about just IT. The ICT, and that is the convergence, the information communication technology. So that means telecom and IT have already merged and converged, and that is what is called ICT. So there are a lot of drivers, and two main drivers are the technology and the connectivity. Because connectivity is what telecommunication, technology is what is IT actually, and both these things together are driving, and they are fueling what is called nowadays cognification. Actually, the future of all these things what we are talking, whether it is virtualization, ITification, the future is cognification. Some example of cognification are artificial intelligence, virtual reality, augmented reality. That is what are knocking at the door. All these things. And cognification, actually, if you go by the word meaning, cognification means you will make some machine who will think for himself. Nowadays, whatever we do, we program. Actually, there is a human angle to that. And as per the program, the machine becomes intelligent, machine becomes automated, machine becomes efficient, or it does your job. That is what till now we have reached. But the next step will be the cognification, and that will be the new thing, which you will see here also. And these various drivers for these things are listed here. A lot of these laws are known to the students, at least. The starting point of any technical presentation will always be the famous Moore's law. The Moore's law everyone knows, and especially here, a lot of computer graduates and professors are there. Moore's law, the processing power of a chip, which doubles every 18 months. And there it started bringing broadband, but how much? 2 megabit, 4 megabit kind of thing. That is not very fast. But now the copper itself can carry 1 gigabit. Recently we have a standard called G-Fast. All these standards in telecom are made by ITU, International Telecommunication Union. So this year only they have brought the copper, the speed on copper, you can carry 1 gigabit now. But earlier used to be carried on fiber, now copper also. So these things are happening, and this is what I was mentioning. So on the copper, you don't have to carry only voice. If you put a DSL modem, and what the DSL modem does, it digitalizes the copper line. Copper line was analog, it was carrying your voice. When you put a DSL modem there, so it digitalizes it. Once it digitalizes it, it has a lot of advantages in addition to increasing its capacity to carry signal. And now inside also a lot of developments are happening because of the Cooper's law. And now we are talking of 4G. There are a lot of technology which are working on mobile side. The one of the technology is called Wi-Fi. Wi-Fi everyone knows, of course. Then there is a Wi-Fi, white space. It makes use of the white space, its range is more. And then the latest thing which is coming, that will revolutionize everything on wireless. That is called POW. You may have heard about PoE already, power over Ethernet. That is no brainer. But there is a POW. The POW is power over wireless. So what will happen now? Everything goes over wireless. Your signal, your TV signal, I think up to 4G, you already know. This is a diagram, I call it 7 cloud diagram. The 7 cloud diagram basically what it does is, it takes the broadband to home by whatever is available, making resource which is very, very scarce. In that resource, people have to serve so many customers using different technology. For that also, a lot of changes are happening, and that is where Cooper's law play an important role. Normally, the information carrying capacity of a radio channel is decided by what is called the famous Shannon's law, Shannon's theorem. If those are from communication, they will know this last line, C equal to B into 1 log to 1 plus S by N. That is what. So information carrying capacity of a channel is decided by the quality of channel. The computer guy will call it disaggregation. Divide and rule kind of policy is used here also. So what you do is your total network you divide into different layers. And learning is from the internet only. Internet we had a OSI model, 7 layers were there. So instead of those 7 layers, we have grouped them in 3 layers. All the functions of the 7 layers are grouped into these 3 layers. One layer is called the transport layer or the media layer, that is your infrastructure, the underlying infrastructure, which will carry all your switches, all your cables, routers, modems, multiplexes, gateways, everything is put in that. That is one layer, the underlying infrastructure. Then you have another layer which is for the service control. So what you are doing is, you are separating the infrastructure and the service control function. Infrastructure is separated into one layer, that is your main layer, and then the service control function are given to what is called a service control layer. On internet it is called session control layer actually, the 5th layer. So there the service control functions are done, and for that there are some devices. And on the top of that you have an application layer. These days the service control is just one part of this, and service is just one application, you can say, the basic service, the connectivity. Service is nothing beyond connectivity. But connectivity is not enough. Now people want so many things. Value-added service, enhanced service, over-the-top service, so many things. So those are controlled by the application layer. So 3 layers are, the total network is divided into 3 layers. Software-defined network, which came long back, and the open innovation, because these days innovation is the buzzword. Whatever is the normal concept or a normal network. In a normal network, what happens? You have a physical layer, you have a transport layer, what I shown. Then you have a network infrastructure, those specialized switches, routers, transponders, all those things are there. And then you have your IT. IT will always be there. What IT does today? IT does a back-end job. IT does administration, management, billing. All those functions are done by IT. So IT is still there even today.
I have a question.
Which one?
I have a question.
Oh yes, if it time permits.
The purpose of my life is work-life balance.
Okay.
But purpose of my life is work-life balance, and I want to live in India. What should I do?
I want to
Live in India.
No, why purpose should be work-life balance? Purpose should be to be more productive, more efficient, happy, useful. Work-life balance is a tool, not a purpose. So your purpose is not defined properly. So you first define your purpose. How you achieve that can be seen. The work-life balance is a process, not the purpose. Purpose is what you want to be, what you want to achieve, what you want to contribute to society. Those kind of things should be purpose.